Hi everyone. Today we're discussing about what are confidence interval in statistics, what is the mathematics, and what is the intuition behind it. So let's get started. So you all must have heard of what some concept around confidence, and you must have heard of this term if you have been in the data science space for some time. So before jumping on to understanding what actually confidence intervals mean, we first need to understand two major concepts in statistics, that is population and sample population. Let's get started. So population refers to all the samples that represent a certain section. For example, if you wish to calculate the average height of all Asian males, then all the Asian males would form our population. Similarly, if you wish to calculate the average marks for mathematics for a particular class, say class 8th B, so the population here would be all the students of class 8th B. Now, if you would have noticed in these two cases, we would be facing a bigger challenge in the first case for collecting any data set, because the number is very high, the population is very big, and eventually collecting data from each of the member of this population is very difficult as compared to the second case. Because in case of the second case, the class 8th B students, the number won't be same, not more than 500. But in case of the total Asian males, the number would be in millions. So collecting data in the first case is a bit difficult, but there are statistical studies that has to be carried out. So what to do in these cases where we can't collect the whole data for the entire population? In that cases, we come to the concept of called as samples. So sample population is nothing but a portion of the population that we consider for our study. So for example, it can be the case that we have a population of say 10 million Asian males, out of which we consider just 10k Asian males for our study for calculating the average height. You got my point. So we are not considering the whole population, but we are considering just a section of the population. Now, once we calculate the required stat, so for example, we are calculating the average height of Asian males. So this stat will calculate over the sample population that we have considered. Now, using this calculated stat for the sample population, we will try to use the same number for the whole population as well. Now, this is something fishy. This is not something correct, because we have a big population of 100 million males, and eventually, what you're saying is that we are calculating the average height for 10k males, and eventually are using the same number to represent the average height of 100 million. That is not correct. It would be a very uncertain number, right? The value might roughly be the same, but it can't be point to point accurate. I'm correct, right? So, whenever we have such cases where the data for the whole population can't be collected, and we rely on collecting data from sample population, and second thing, we are making some sort of an assumption. In that cases, alongside the estimated value, that calculated stat that we have got, we need to attach some sort of an uncertainty factor as well, to tell the people who are reading about the study that this is the uncertainty that is attached with this number, right? Because we are not considering the whole population, we are estimating it, we are not calculating it. We just need to remember this. We are calculating the stat for a sample population, but using that number, we are estimating it for the whole population, which might contain some errors. Now, confidence intervals helps us in adding this uncertainty factor uh, to the estimate we make for the population using the sample population stat. So you must have heard of statements like this. If you are going to some research studies, according to a study, the average height of adult male in the population is 175 centimeters, with a 95% confidence interval of 170 to 180. Now, what does this mean? It actually means that they might have conducted some study over a sample population, got to a number 175 as the average height. Now, they are sure that 95% of the time, so if you conduct such a study over random population, random sample population, so out of 100 studies, 95% of the time the value would lie between 170 and 180. This is the whole meaning of confidence interval. So this is was the actual stat that was calculated over the sample population, and eventually deciding over a confidence interval, we have calculated an lower and an upper bound. Inside it, we are pretty sure that 95% of the time the value, if we are conducting such a study again, the value would be lying between these two numbers, and the average height of the adult male should lie between these two numbers. We are 95% sure. So confidence interval helps us to get to a range rather than an exact value, alongside a confidence score as well. That is the uncertainty factor that I was talking about. One thing we need to remember for while calculating confidence interval is that when the population data is available, any stat you calculate is exact, and hence no confidence intervals are required. It does make sense, right? Assuming that, like, if you are calculating the average score of mathematics for class 8 B students, so in that case, all the possible samples of the population are available with you. So you are calculating the mean over the data of the whole population. Hence, no estimations are done, and that is why no confidence intervals are also associated. It is an assured value that we have got. So confidence intervals are something that we would be using when we are not considering the whole population, or when you are making some sort of an assumption, as told you earlier. Also, higher the confidence, the broader is the range. It does make sense, right? So the broader is the range, lower are the chances that we would be making a mistake, and hence we are higher at confidence. That's the case. Now we'll be going to the mathematics. The mathematics is not that difficult. So first of all, we'll be generating n random sample populations of size say r. So assume that n to be 10, assume n to be 1000. So we'll be generating 10, we would be generating 1000 random sample populations, where each population consists of R samples. Assume R to be some number, say 100 or 10, whatever. Now we will be calculating the required statistics. So the stats that we used to calculate, we'll be calculating it for the sample populations. Assume that we are calculating average height. So we'll be calculating the average height for each of the sample population, for all the n sample populations that we have. Now we will be setting up a confidence interval. Assume that the confidence interval that we are going on with is 95%. So we need to calculate a value x, which is given by the formula 100 minus z upon 2. Z is the confidence interval. So if z is 95, then x equals to 2.5. Now we need to calculate the x comma z plus x percentile value from the average height stat that we have calculated for the n population. So if you think the we have calculated average height stat for each of the random population that we sampled. Now this will lead up to n height stat, one for each random population that we have generated. So we would be arranging all these numbers, all these average heights for each of the populations, and then we'll be calculating the x and z plus x percentile value. So that would be, in our case, as you have taken 95% confidence, it would be 2.5 and 97.5. So the values that would be lying on 2.5 percentile and 97.5 percentile would be forming our confidence interval at 95% confidence interval for the average height that has been calculated. So in this way, we will be getting a lower and upper bound for the confidence interval. So we will be calculating 2.5, 97.5 percentile score, and eventually we will be saying that as x hyphen y is the confidence interval with confidence 95%. This is how confidence intervals are calculated, and this is the whole intuitive meaning of confidence intervals.